Hello, welcome to the Purdue ROV Eagle tutorials. In this video I'm going to be showing how to make interfacing connectors between boards that connect together. This is something that's really important to do late in the design cycle because there's just a lot of things that can go wrong with it. Spacing between connectors that's off, the boards might not be able to plug in, one could face backwards, pinout could be mirrored, signals might not be routed, some of the boards might not fit. There's a lot of pitfalls here. The goal of a good connector between boards should be to prevent all of this. And as I kind of said, this should happen later in the design cycle just because it's restricted, which is good because it restricts you to only doing what works. But earlier in the design cycle, as you're changing more things, you probably won't want to do this because you're changing more things and it makes it harder, so you have to constantly be updating connector, going back, renaming it. I wouldn't bother with that until you have something locked in and ready to say, yes, this is final, this is good. So first up is the signals between boards. Here you can see we have two just giant blocks. There's a number of things that are kind of missing here. There's not a name on it. It's all the pins are just P $ and something. There's two ground blocks. It's not indicated why ground is in which spot, why some of these are not connected, and then there's these three here, programming select, can high, can low, 3.3 volts. If we look at the backplane, programming select actually wasn't routed on here, which is an issue. And again, something we want to try to prevent. So we're going to go over to the part and so we'll put 12 volt at the top. Generally, higher power voltage makes sense to put it there. Ground at the bottom, and then we can just do 3.3 volt on one side, programming select there too, and then can high, can low on the other. If you really want to get fancy with these, you can also define the pin directions for them, which allows Eagle to make or to go in and do some other checks and just see which properties, or if you're violating something, like maybe you have two outputs on the same line, or two inputs somewhere without any outputs, that kind of thing. We're not going to bother with that, though, especially for this tutorial. So. And I'm trying to keep the center there in the center and pretty beautiful. And then lastly, we're just going to slap a name on it. There we go. Great, so now we're going to go on to the footprints. You can see there are some of the footprints here. One thing that actually was done fairly well with this connector is the keying of it. There's kind of multiple levels of keying you can do. You could literally not key it and someone could plug it in backwards and, well, things could go quite badly then. This one, you'll notice the one on the right side has one fewer connection, so it should be pretty obvious as you're plugging it in that the one with the appropriate amount of pins, smaller, goes on one side, and then more pins goes on the other side. But it doesn't necessarily prevent you from doing anything like that, and if you misalign things and are off by one, you could still plug it in. But again, this was decent. We're not really going to mess with that this time. Some things that could be done: offsetting one side by half a row, or part of it that way. So if say all of these pins moved up by 0.5 or 0.05 inches, then it would prevent you from plugging it in at any misalignment. And that's generally a pretty good solution. Also, certain types of connectors will just not let you, if there's a mix of blades and then a signal block, it should be pretty obvious how to plug it in correctly. So we're going to go back here. And then we're going to rename all of these to match. This is also missing a keep out layer. One thing also to do in doing those is we're going to go through make one for the ESC first, and then just copy it over, but change some of the things like keep out for the backplane, which will have the keep out on the opposite side. So first up, the pins. Let's see, if we look here, we want all the 12 volt pins to be P9 through P13 and then P23 through P27. That's on the other side. Let's see if I can One thing, looking at these here, it looks kind of like the actual solderable copper part of it is a little small. So I think I might boost up a little bit at the end. It's something, and depending on the board manufacturer, some like JLC will give you a little less. Advanced Circuits is usually pretty on point. So is Oshpart with how much copper you get here. If it's really small, it becomes hard to solder the pin, especially for something like this where it's 12 volt current. There's a lot of current going through the polygon, the copper on the board, so you have to heat it up a lot. It makes it a lot easier if there's a bigger solderable area to contact your iron with. So then we need to go to the other side and also do, let's see, 12 volt. Right here, A through E and O through S. That's all like 12 volts. Let's go back and do ground, which looks like it's just the opposite side, same number. Let's start over here. So that's all the grounds, and then we should have 3.3 volts G, H, U, and V. Then these are no connects. Let's see, does it multiple connects? No, it doesn't. So here we have select high and then low. And I didn't want too many ground. So another thing you can kind of see as we're doing this here, there's a number of no connects. Sometimes it's nice, like here, if you were to misalign this side by one, nothing bad is going to happen. I'm not sure on that side. Really, you should just plan to prevent people from misaligning it, not just stop bad things from happening. But that is kind of a nice feature to it. So, and then I think that, yeah, that rounds out that part of it. We're going to put our keep outs in now. So we'll do the backplane one first, I guess, just because top feels a little more natural to do. So that's all for that side. Then here, these are nice because then you can see which layer of the board it's on. You can check that it's not flipped to the wrong layer or mirrored to the other side of the board. And Eagle will actually tell you if you put something inside of this or if it's intersecting with it. It's like, hey, I don't think you should put this here. It's going to run into another thing. And I don't think we have a name one here either. And another thing we're going to be doing with this is putting in an outline of the ESC board. That's really important. Just making sure that you know how big the board is, how much space it has on the backplane. That was actually one of the issues when this was first ordered, and you'll see it later. These boards are all actually too close together. And you have stuff like this connector here that you don't want to run into. So, these are nice to make on the documentation layer. That way you can see it while you're editing it, but usually the documentation layer is not actually printed on the silk screen, like something like the silk screen with the names layer, sometimes the values layer, or yeah, too. So we'll just look at where the board is. So we need 1600 length. And of course this is shoot. So first I'm just going to put it so it's a little closer at least to how the board goes. Then we can worry about fine-tuning it in a moment. Actually, do. That's right, that's how you should do this. Nope. We'll line all of this up like it should be in the board, and that'll make it pretty easy then to make sure that where we have the board, everything is actually placed properly, because the lower left corner will be in the lower left corner of the origin of the board. And I messed this up. There we go. So, if we look at the board, right in between here was at 2100, 1450. So is this at 1450? Oh, it's a tad low. I think that puts it where we want it. Yeah. Then let's see, this should be moved over. What's that? 1450. So that's already So there should be 1400, or sorry, 2100, so that should be moved over by 120. We'll change the grid size just to make things a little easier. There we go. So now, okay, so the average of these two, where that origin used to be right there at 2100. Change the grid back. You can see the, yep, up in right there, 2100 if I have it there. Sweet. So we were going to save this one. That was the AC to backplane whole, and then we'll duplicate this. And we're going to name it then, well, whole BKP for backplane. Or wait, that was the backplane. So we'll go back here, the ESC one. So for this one, then we are going to change the layers of this to be bottom documentation and the T keep out to be bottom keep out. Really, I think these are also silkscreen layers. Oops. Here. Yeah, T-place, but I'm not going to bother with those right now. It is something, though, to make sure that you solder the connectors to the right side of the board, but hopefully you should know that, especially with the hints of the keep out layers. So, save this, then now it's simply a matter of making a new one. Is Backplane. So there's actually two ways you can do this. We can make two different kind of packages, right? Or two different devices, or we can make variants of them. So I'll kind of show both here. So there, another thing to note, when you go back here, depending on what you have, and what you start with, sometimes you'll have a pin swap turned on. Not a good idea for here. You generally want to prevent people from swapping pins, because if they swap it, they'll swap into something that is wrong. You know, something else expects it to be 3.3 volt in a certain spot, and if you swap it, suddenly it's not. So we'll grab this one, and the variant name. This one's the backplane. Connect it, so 3.3 volt should be pretty easy. You go through, find 3.3 volts, 12s, can high, can low. Then you got ground, and you got select. And then I guess I'll show the variant way. So now we have another one. This is for the ESC. And we'll go through and connect those just like we did with the backplane variant. So now, if we go in, we can we'll add our part. So here you can see there's the two different variants for it. We're in the C board, so we'll grab the ESC footprint. So looking at it now, we can see pretty clearly, 3.3 volts hooked up to 2.3 volts, same with can high, can low, all of that. And because we just copied the footprint between them, we know that they match up and work. And then, it should be pretty simple. And I think if really I could have just replaced this part. Because now when we switch them in, all of the routing is going to be lost, but it's only just the first intersection until the other one. So you can see it's right on top of it, hence all the conflicts there. Oops, just deleting the schematic. So here we can see, 12 volts in the right spot. We still have our no connects. 3.3 volt. This was routed with a planes or a polygon, so that's fine. Oh, it was actually stuck around. There's programming select. This was actually an issue with the board that it wasn't routed. Previously it wasn't clear. There's just another pin there, but now, programming select. It's not routed. And the outline matches up very nicely with the documentation later to show that connector is in the right spot with all of it and it fits. So we're going to go over to the backplane and clear out one of these to pop the new connector in. And so this time we want to grab the footprint with the backplane version. So one thing I could have done, but I didn't because I was kind of rushing through, is these are being shown kind of duplicately. It's nice to know, okay, yes, I connected the can high signal to the can high pin, but you can actually turn off showing both of these in the schematic. And that's something you might want to do. You can still go and check it in the part that everything's connected properly, but it's not really something you want to do on the, or it's not something you want to have to look through here every time. You just have to kind of clutter up your schematic. Yeah. So this is something where programming select was not routed on the original backplane. Yeah, I think I'd say it was, I made a mistake, it was routed over here. I think. No, yeah, it was, I think it was on the connector, but it never actually made its way over here to the mux where it needed to go. So, yeah, there's a output enable here that I think the programming select was supposed to control. Anyway, back to the backplane, we got that, and we just need to connect our... Actually, I do need to do this for another one to show. this one, fortunately, is easier. You can just copy this. And of course, you rename programming select because they're supposed to be different for GSC. Alright, we are back. I was having some eagle licensing issues, but it should all work now. So we can go ahead and place these in here. There's the first one, and the second one, lining it up on these polygons. And yeah, you can pretty clearly see the issue here. These two boards overlap a lot, which means that you can't actually place all three of these together. So another one of the headaches and issues that can be avoided by actually going through and doing a good job making these connectors in between boards. So, yeah, as you can see, there's not any programming select signal routed to that one. Thank you for watching. I hope this really helps when you're making boards and getting ready to order and preventing any of these issues from happening. You know, as the saying goes, you don't need to make all of the mistakes yourself.